I had a request if I could go through something similar to number 4 and 5 on the worksheet. I'm going to go ahead and do number 4. First thing I'm going to do is let's write out that fireproof form that we talked about yesterday. We've got y plus or minus over, and you've got sine or cosine. We'll deal with the first one, which is cosine. Same thing over here. You've got plus or minus, and then you've got a value in the denominator. Remember, this piece that's sitting here is your amplitude. Whatever we place here is your vertical shift, and it's always the opposite of the direction it is shifting. Whatever we place in here is our phase shift. And that whatever we put down there, when we multiply that times 2 pi, that will be the period. So first thing I'm going to do, and if you think about our notes, we actually started with the vertical shift. We did vertical shift, amplitude, phase shift, and then we ended with a period. So I'm going to do the same thing we did yesterday. The vertical shift is the same thing as your midline, and my graph got cut off just a little bit. But if I remember, this one went all the way down to, if you look at yours, I believe this goes down to -6. So the distance between -6 and +2 is 8. So the middle of that would be 4 units. Another way that we talked about finding that, again, that's that vertical shift, and I'll put down just VS. It's the same thing as your average. 2 plus a -6 divided by 2 ends up putting me at -2. And if you count that out, 1, 2, 3, 4 to get to your max, and 1, 2, 3, and I know our graph is cut off, but 4 to the min. And we are going down, so remember we're going to do the opposite. We've got y plus 2 over. Our amplitude is the distance from that midline to the maximum, or that midline to the minimum, which this case would be 4. We're doing the cosine here. We've got x. Now, our phase shift, we have to make sure if we're doing the cosine that that initial point starts at our maximum, and the first maximum that I see is right here. That would then correspond with our phase shift, which is equal to pi over 2, and again it's a minus pi over 2 since it's the opposite of shifting to the right. And then finally I have to find the period, and you can pick any 2 points that you want to count out that period. I'm going to pick just this point and this point right here. Every box is 1/4 of a pi, so that's 1/4, 2/4, 3/4, and 4/4. So my period is equal to pi. Whatever I place here, when I multiply it by 2 pi, has to give me 1 pi. Now, if you couldn't do the math in your head, you're thinking 2 pi times a has to give me pi. If I went and did the math, I divide by 2 pi, and we end up with a is 1/2, which is the same thing that we got when you think about it logically. Finally, the calculator form, or the friendly form, means we just need to put this in y equals form, and we did a few of these yesterday in class as well. I'm going to multiply by that amplitude, so we've got 4 cosine. I'm going to leave that part alone for just a second, and a -2. This tends to be the difficult part to simplify. I'm dividing by 1/2, which is the same thing as multiplying by 2 over 2. 1/2 of 2, well, that cancels out in the denominator. I'm just left with 2 times each of those terms. We've got 2x minus pi. The only difference if we go and write the sine function is going to be the phase shift. So let's take a quick look at that. Everything else stays the same. The only difference is, as I said, is the phase shift. In this case, we want the intersection of the phase shift and the vertical shift to be the origin, or that first point that's on the graph. So if you take a look, if I went and drew this line in here, This is acting as my x-axis, this is my y-axis, and notice that graph hits that point as well. This ends up being a phase shift of pi over 4, and it's going to the right, so I put down minus pi over 4.